Hello! Today I'm going to be giving an introductory overview of the Global Positioning System and how it implements topics that were covered in this course. My name is Sarah Novit, and I will be covering some background information on satellites, the history of GPS, how it operates, and electromagnetic applications. GPS satellites are pieces of equipment that span 18 feet in length with two solar panel wings on either side. They use these panels as a primary power source, although there are nickel-cadmium batteries as backup sources. They orbit 12,000 miles above the ground at 9,000 miles an hour, so that it takes them a total of 12 hours to reach a complete orbit. The most recent launch of a GPS satellite on February 5, 2016, cost $131 million to build the satellite, contracted with the Boeing company. Once they are in orbit, GPS satellites emit synchronized signals that are timed by an atomic clock. These waves travel at the speed of light in order to accomplish the functions that will be discussed later in this presentation. The GPS was invented by the U.S. Department of Defense, which launched the first satellite in 1978. At first, this was only used by the U.S. military until it opened to the public in 1983 at a much weaker signal. This was changed in 2000 when the public signal was not intentionally weakened and everyone was able to access the technology. There have been 4 types of GPS satellites in orbit as of now. GPS II-A have been completely decommissioned as of 2016, but there are 12 II-R, 7 II-RM, and 12 II-F satellites that are still operational at this time. The satellite mentioned before that was launched in 2016 was the last of the II-F satellites. The GPS III satellites are expected to be launched no earlier than 2018. It should be noted that there have been similar systems set up by Russia, China, and the EU, but they are on much smaller scales. The US GPS is the system that is capable of being used worldwide and will be discussed throughout this presentation. GPS is set up in 3 segments. The first segment that we have been discussing so far is the space segment. This comprises of the expandable 24 satellite configuration. The US promises to maintain 24 operational GPS satellites and are currently flying 31 to maintain that promise. They emit frequencies at 1.575 GHz and 1.228 GHz to give their location and time. There are always 4 of these satellites located on the horizon at a time. The user segment is the handheld or vehicle-mounted receiving device of the user. It is the central point of 4 satellite ranges. Due to most common technologies using quartz timing, they usually have a time offset error compared with the atomic clock of the satellites. Finally, the control segment is the network of 5 ground stations around the world that provide updates to the satellite times and locations. The main center is located in Colorado Springs, with stations in Ascension Island for the Atlantic Ocean, Diego Garcia for the Indian Ocean, and Kwajalein in Hawaii for the Pacific Ocean. Now, it is time to address how the GPS applies concepts from this course. In Chapter 3, we cover the transformations between coordinate systems. This is important because the GPS uses the Earth-centered Earth-fixed coordinate system, where the center of mass of the Earth is the origin of the Cartesian coordinate system. The satellite emits a circular signal and measures the time that it takes to reach the receiver, TS. After accounting for the receiver's time offset error, TR, this time is multiplied by the speed of light, c, to find the distance between the satellite and the receiver. Once this distance is calculated, using the known satellite position, XS, YS, ZS, the receiver position, XR, YR, ZR, can be partially determined. However, the first satellite only knows the radius of the circular signal at the point that it reaches the user. It does not know where along the circle is the user's exact location. Therefore, the trilateration technique is used with 3 satellites all emitting a circular signal. The point at which all 3 signals meet is the official location of the user. Currently, 4 satellites are used in this way to determine the user's location to help account for the time offset error of the receiver. As you can see, although the ECEF coordinate system follows the Cartesian coordinate system, the satellites must account for their elliptical orbits, the Earth's circular shape, and the circular signal that they emit. At the beginning of this presentation, we covered the basics of GPS satellite signals in operation and the history behind the GPS. We followed with the operations of the Global Positioning System with space, user, and control segments. Finally, we talked about how the GPS used transformations between coordinate systems in combination with the trilateration technique in order to fully pinpoint the location of the user down to the meter. It's incredible how much this technology impacts us on a day-to-day basis. Here are the sources that I've used for this presentation.